term. The first of all, it was a small typo here, but it is not our today revision. Here there is a transpose T. Okay? But we do it later on. This is not for the SVD. Let's start here. Okay? So I need your contributions, how to cancel this one together, please. So from here, we have x1 and x2. x1 and x2 are vector or a row or column vector? According to the definition. Vector, right? And vector, of course, I mean row or column? Column, right? Because we have the T transpose. Okay, so here, if you want to ask what is the X data. So what will be our X here? For example, if I call X it will be the X1 and X2, right? So it will be in this case here 1, 2, and 2, 1. Do you think here if I put xt transpose, is it equals to X or not?
Yes.
Yeah, because the matrix is symmetric, right? It doesn't matter.
Yeah.
Okay. Okay. Kernel function. What's the definition of kernel function, please? Xi and xj. When I put triangle, what does it mean? By definition. What is it, please? So now we go into the other space, right? So what do you call it? Phi, xi, phi, xj. Well, I have to put the transpose here, please. And y. Okay, kernel of two vector. Is it value or vector? It's a value. So to make this one value, where we have to put the transpose? At the first or the second? At the first, yes, exactly. At the first one. Clear? And here, specifically, we call it the quadratic kernel. What is it? Xi, xj transpose, we put the square, right? Okay, so this is given. Sometimes we use Gaussian, sometimes we use different kernel function. In this specific, we call it a quadratic. So sometimes I'm solving, and sometimes I'm doing a revision, right? What is K now, kernel function? By definition, what is it? Okay, what is the size of the K, for example? I can ask you, what is the size of K? Supposedly we have n features and the size n. Suppose. What will be the size of K? N by n or m by m or n times m?
N by n.
N by n, thank you. Okay, so here it will be n by n. And everywhere here, what you need to put here, please? Kernel xi, xj. How we can write it, please? Okay, so this we have, let's go to the other side. So supposedly here we have x1 until xn, so the size is m times n. We're going to reach space, we call it phi x1 until phi of x n. Clear? What is the size here? Number of columns? N. What is size number of row? Something we don't know is something but bigger than m, right? Usually in general. Okay. What we call this one? We call it capital X. What we call this one? Capital Phi of X. So this is matrix. Those are vectors, right? So what is kernel here, please? Kernel is phi x times phi x. Where we have to put the transpose? So the size is n. What is the size of this one? We can let's call it R, as he said, R times N. And this is R times N. So you have to put the transpose at the first one to be M, N. So the way how you can get it if you want. Can we write this one differently also? It can be written as, we have another way also. It's written as sum of phi xi t, phi of xi and I going from 1 until n, the same way. Just we can write it differently. So in this our case, what will be here? So what will be colored here, please? Phi x times phi x. What transpose we do the first one, right? What is phi of x here? Phi of x1, phi of x2, right? Transpose times. Clear for all? By definition, right? And of course, this is okay. What should be here, please? Let's calculate this one. Okay. This one, can I change it to something like this to make it simple? Phi of x1 t, phi of x2 t. Same thing, right? Yes? Because it transpose, right? If you do transpose of this one, the row, the column became row. That's all, right? Okay, let's do the product here. First one, then the second one. What is it? Kernel of x1, x1, right? Second one, kernel of x1, x2. Here, kernel of x2, x1. Here, kernel of x2, x2. Right? What is kernel? It's just the dot product square. Because this is dot product, right? It's a number, right? Okay, let's do the dot product please here. The first one with itself, what will you please? 1, 2 times 1, 2 is 1 times 1, 2 times 2, 5. Correct? 5 squares. X1, look at this one, then itself is done. X1 with X2, what is it? 2, 2, 4, 4 square. Okay? Second one, 2 with 1, if it's symmetry. And here, this one itself is 5 square. So we got the color. Yes? No, here I'm doing a revision at the same time. But to answer the question, that's directly here. No need to all, yeah? I'm just surfing with you to revisers, okay? Clear for all? So you can answer directly here, right? Okay? Directly 25, 16, 16, 25, right? Okay, next one, find the norm of the two. Okay, tell me how to find the norm. So if you have a vector like this, right? What is the norm of this vector, please? What is the norm of the vector? The norm square, right? It can be vt times v under square root, right? So now what we have here? I have mu, define this one, mu 5 times t under square root. Do you okay with that? By definition, right? Okay. What should be the definition here? Let's do it. What is this one here? Transpose? We do transpose of this one, right? So half, I can put it here 1 out of 4. So it will be here phi of x1 t plus phi of x2 t times itself, right? So I'm just putting the definition, nothing else. Now we expand the bracket. Yes? Okay, let's do this one. This time, what is it, please? It's kernel 1, 1, right? So it will be here, again, you can see at the end? It will be 1 out of 4, what will be here? Kernel of x1, x1, right? Next one. This with this, what is it? Kernel x1, x2, right? Okay. Another one. This with, it's same thing, kernel x1 and x2, or x2, x1, doesn't matter. So what they do here? 2 times, right? Plus, last one, kernel x2, x2. Do we have everything here? Because they are from the table, right? 1, 1 is here. This, plus this, plus this, plus this, yes? So at the end, what I'm doing, I'm adding the entire matrix, all the elements, right? Okay, so it will be here, please. It will be 1 out of 4 times 25 plus 16 times 2 plus 25, right? All under square. Is it difficult until now? So what we do, we just apply formula. I just apply this one to calculate the first questions, and I apply the second formula to answer the second question. Nothing else. Okay? And of course you have to know this definition here, like this is line, right? How to define the kernel functions. Try to think about the third one. So we would like to center the feature space. Yeah, the value. Here we get. Is here, the red one, 25 square, that's all right. I didn't do the calculation until the end, let me check. Honestly, I didn't do it, but let me, here, even here I didn't do it, I keep it like this, it's fine. Okay, try to do the third one, please. Tell me, how do you center the data, please? First of all, if I give you a matrix, any matrix, how you center the data, please?
Minus the mean.
Okay, so if I give you a data x, okay, this is x1 until xn. How to center the data, please?
Subtract the mean.
How to make it? x1 minus mean until xn minus the mean. Correct for this one? Okay. But the way of writing this one are the same with 1 and 2 or not? Okay. Here I put x, right? I can put, doesn't matter, I can change it to kernel space, right? I can put 5, right? Doesn't matter, same thing, just features. And it became the mean of the new space. Okay? How to kernel this one here, please? So this is my phi of x, all the matrix. Yes or no? Or we don't need to do this one. Okay? So what will be here? I need to subtract what? The mu, right? Do you agree with that? Same thing, right? Yeah. Okay. So do you think this way of writing this, is it the same thing like 1 and 2 or not? Can you check? And in the solution there is some.
The one is transpose.
Yeah, T transpose, yeah. Look here, this is fine, it's the same thing, right? But I have to repeat it n times. n in this question is 2. So how to do it, please? Do you think, look here, try to multiply this one. A, B, C, multiplied by 1, 1, 1. What you get, please?
ABC.
What will be here, please?
ABC.
A, B, B, C. Correct or not? So what we can say, I just remove this one. This one, and multiplied by y, 1 transpose, and the size should be n. In this one. Clear the idea? Yeah, if you multiply ABC by 1, 1, 1, do the multiplication. A times 1, A times 1, A times 1. You get this one. So the same vector, I repeat it 3 times. So this vector here, I need to repeat it n times. So 5 multiplied by, let me write this one it's like this, huh?
How about the phi?
1, 1, 1, 1, n times.
The phi is not, so I could all over all.
Which one?
The phi is.
Yeah, I think. No, later on. I'm coming to the first one. So Anthony is okay? So what do you think? 1 is correct. Yes? Can we do the second one? Yes.
Here you are doing theta x1 and theta x1. Isn't it theta x1 and x2?
Just a second. Until 1 is okay now? 1. Perfect. Then.
No, it's theta x1, theta x1. Why is it like that?
No. This is 2. Yeah, thank you. Thank you. Yeah. Thanks. Yes, perfect. X1 and x2. It's a mean phi of? Phi of.
I did not answer the question because of that.
Really?
Yeah, all of us.
Yeah, all of them.
We thought there was a mistake.
Let me check. Yeah, all of them. Yeah, you are right. Yeah, thanks. Just a second. Yeah. Here, okay, right? 1, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Yeah. Thank you. Thanks. So, I is correct. Any question until I before going to 2? Is it clear this one or not?
I assume we are multiplying by the same value. We are just doing the first.
Okay, here, do you agree with this one? When we have a matrix, we have to subtract the mean for each column, which means exactly this one. Because this, if you multiply it by 1, 1, 1, it's like you are repeating it. So matrix minus the mean for everyone, so at the end it is something with that. So the I is correct. Yes? Is okay for all or not here? Yes? Not clear? I can repeat again, please. It just you have data, I'm just removing the mean for each column or for each vector, nothing else. Because the new matrix, it will have what? 0 mean. That's yeah, something. Try to the second one. Do you think is it same thing or not?
Yes, it is. Because we have the formula for the mu of x, it's equal to the summation
But here there is no plus. It is phi. Yeah. And this say is wrong or not? Okay. Let me do this one first here. If I have A, B, C, D. Shall I multiply this one by 1, 1, 1? What you get, please? What will be here, please? A plus C. Next one. A plus C, right? Next one. B plus D. B plus D. Let's try, we multiply by half, for example. What will be here? Or is the mean, right? So the mean is repeated 2 times. So at the end, to find mu, what is it here? 1 out of n, the entire matrix X, we multiply by 1 n times n. Okay? 1 multiplies by 1 by n, you get the mean repeated n times.
Why you change
x1 to x2. Ah, okay. I changed it because it was typo. Okay. Do you agree with me? We have x1 and x2, right? We went to the new features. What is it? Yeah. This is matrix. And this we call it, all 5 of capital X. So we can say, if I don't put index, mean the entire matrix. If I put index 1, 2, I, means specific vector. Which line are you talking about? Sorry. Here, x1, x2, x3. So this is a column only. If I put without 1 index, mean the entire matrix. So please, this is good questions, yeah. So please, if I put like this, what does it mean here, please? This is the matrix. If I put something like this, mean just specific vector of the new space, okay? Clear? So here, for example, what is this one here, please? This is vector, this is vector. All this one here, I will just call the matrix as 5 of x without specifying the index. Clear? Yeah. Okay. So, do you agree with this product? You get this one? What is this one here? What is this? Is the mean here, right? What is this one? The same thing, the mean. So to find the mean, just multiply by the square 1 matrix. Okay? So what do you think? The second one, is it correct or not?
Yes.
Okay. The first part of the second equation is correct, as I did here, right? Second part, what do you think? Is it the same thing or not?
Because we have to
I just,
subtract the mean.
what we did here?
Subtract the mean.
We took the something common factor. You see here, this is the same, take it common factor, but of course we cannot put 1, right? We are in matrix, we put identity matrix. So it will be I minus half 1, 2. So it's correct, both of them are correct. So I'm just the way how to writing in matrix way only. You are really silent. Is it so difficult, you think?
No, we have to focus.
Yeah.
We have to-
But this is all, honestly, this is, the technical is coming from linear algebra.
It's not really straightforward. You have to think the way the assembler thinks.
Yeah, so
Because
it's,
you have to, for you to answer it, you have to go with the same assumption like you put half and
yeah, you have to, yeah.
It's not really like.
It comes with time, yeah. The more you do, it will be easy for you. But you have to. But the most important, did you understand the steps?
No, the steps are clear, but the concept.
It's about to
Yeah. Honestly, this course in certain university, they need 7 prerequisite courses. Yeah, if you want to go faster, you need to be sure. But you have, but you have here the time. What I'm doing, I'm giving everything for you. So you need the time to understand it a little bit. And you are, I think most of them you are worried only about the grade. Forget the grade at the moment. You are at graduate student, you have to think about understanding. The grade later on. Okay? Until now, is it clear or not, please? Okay. Let's go to the next one. Find exactly what we did in the question 1, redo it again with the centered data. Nothing. So you see here, we are looking for this one, but the new data will be this one, right? Because we remove the mean for each one. What is the definition of K as we solved the first question? What was? Always starting by the definitions and do some steps. If it's not correct, at least you get 50% of the grades. So definition is really important. Okay? So, what is K here? Karen, what is definition? What we did before? 5 times 5. When we have the T? The first one, right? Now we have a new, we modify the matrix, right? What is the matrix here by definition? What is it, please, here? It's giving to us. Okay, so this one here, you see this one here? I prefer to use I or 2. Which one is simple for you? I, we have 1, 2, we have 2, and we have 3. I prefer to do the last one, right? What will be the last one, please? Is phi of x multiplied by minus, multiplied by I minus half, matrix 1, 2 by 2, right? Multiplied by itself. Did I forget something? Yes, the T. Yes? Okay. So I did nothing now, I just put the definition now. Okay, the product, when we do the transpose, we change the order, right? Yes or no? What will be here, please? It will be I transpose. I, it is symmetric. You put T or not, doesn't matter, right? Minus half, 1, 2 by 2. You put T or not, doesn't change anything, right? So it will be here. Phi of x of t. This is still the same, I will not touch it. Clear now? What we did, first question, what we did? This one we call it what? This one is just K. I transpose T the same times itself. We have K, we calculated already. What is I? Added in matrix. Okay, let's calculate it. What should be the Peter matrix here? 1, 0, 0, 1 minus half. What we have here? 1, 1, 1, 1. Yes? Times, what is K here, please, to us? 25, 16, 16, 25 times 1, 0, 0, 1 minus half, 1, 1, 1, 1. Easy calculation, right? Just to calculate. What will be here, please? 1 minus half is half. Minus half, minus half, half times 25, 16, 16, 25 times the same thing, half, minus half, minus half, half, right? I can make it more simple. I can take half common factor. Half common factor, it will be 1 out of 4. It will be 1 minus 1 minus 1. Just calculate now. You can get the new matrix. Complex value?
Yeah, eigenvalues of k cap.
We will see it here. See. Now, until now, is clear? I think you can solve it. Is you can find this one 4.5 minus 4.5, which is 9 out of 2. Okay? So the next question it was, so I just put it here. Can I put here 9 out of 2 common factor for this matrix here? Which will be here 1 minus 1 minus 1 1. Clear? This is our K kernel functions, right? How to find eigenvalue, eigenvectors now? Yeah, go. So I will upload all the solutions. Don't worry, please. Just try to understand. I will give you all the solution. Don't worry.
The details is
Yeah, yeah.
important for us.
Okay.
actually.
Just try to. But honestly, until now, is it difficult?
Yes.
Yes, with anger, not with.
If you are explaining it, and the exam, maybe
And the exam is going to be not very hard.
It is not the case. The course is like this. Sorry?
It's not correct. I got exactly the same address in my rough note, and then I didn't put it in my assignment because I thought it's not correct.
Yeah. But yeah, the problem is if you work with data science, you have to masterize this type of techniques. It takes time maybe at the beginning, but honestly, you have to. If you want to develop algorithm or new idea, you have to. There's no other way. If you do apply, something is different here. But even if you apply, you don't understand why. Questions why you have to do this one, why this works, how to combine is. But the most important is you have time, 2 or 3 years, to understand it all step by step. Okay? Sorry?
For the midterm.
But it will be yeah. So this is medium questions, but the others, as you saw, it will be straightforward. Okay. For example, here, supposedly you have K. How to find the angle value, angle vectors? You cannot tell me it's difficult. Honestly, grade 12 IB system, they solve angle value and angle vectors. Honestly, you can check it. A-level, British system or international baccalaureate, they do it. I check it online. Grade 12. But you have to know how to solve it, please. So let's do it together. So please, in order to go through all the papers, do you need to solve it or not? Angle value, angle vector, please.
Yes.
But you can find angle value, angle vector or not for all, please. Yes? No, I didn't get you. You can solve it or not? The angle value. Okay. So let's suppose here, I will give directly the solutions here. So we have the So we have K is what do you say? 9 out of 2. 1 minus 1 minus 1, 1. Which will be lambda here? We have lambda is 0 and 9. What is V1? 1 square root of 2. 1 square root of 2. What is V2? Or C1 and C2 if you want. Like we keep the same notation as before. For example here, if I give you C1 for example, what is C2 without any calculations? No need to calculate. It should be something perpendicular to it, right? How to find something perpendicular to this? Take this one, flip it, put minus up or down, up to you. If you put here, it's correct. If you put here, it's correct. Doesn't matter. Okay? This one here, you can put both minus minus. Still correct, right? Because any directions, you multiply by minus. This or this, doesn't matter.
Doctor, why this is valid? Why this is valid?
To find, if I give you a vector with two only, yeah? Vector of 2 dimensions, to get the perpendicular of it, you flip it.
They are asking for a perpendicular.
Because the eigenvectors on all our study, they are perpendicular.
Because we are always calculating.
Yeah, but here you can do the shortcut. I'm giving you a shortcut. If you want to calculate it, go ahead. So here I'm giving a shortcut. Okay? Is it clear?
Yes.
If you are doing 3 by 3, you find eigenvalue 1, eigenvalue 2. How to do the third one? You can do the calculation, matrices and solving. But there is shortcut. How to do it? If I give you eigenvalue 1, I give you eigenvalue 2, I will ask you to find the third one. We are 3 by 3 matrices. Do you remember a cross product? V1 times V2 is The perpendicular one. Okay? I'm giving that shortcut, but if you don't like it, forget it. Okay. So we have C1, we have C2, so what we can find, this one here, right? Yeah. So we have the eigenvalue, we have the eigenvectors. Yes.
Those are given when you mean like you did all the steps and then you put the eigen.
Ah, no, you have to do it. You have. Ah, no, you have. Right. I said means if I give you, for example, a question like this, just suppose the question. You have matrix 2 by 2. I give you one eigenvector. I ask you what is the second one, without giving any information. How to do it? Perpendicular. Clear? One of the questions. So I'm solving at the same time I'm giving extra information. We do cross product. Yeah, because cross product, you remember cross product? This times this, like this, you're turning like this, you're turning up. Cross product. It's also, yeah, you can. Yes.
How can you find number 2, as you said now?
Cross product? Who remember how to do cross product? Cross product? We do determinant, I, J, K. You put the first vector and the second vector, and you do the determinant. So,
You will give them the
but oh no, don't worry. But it's good to have it, okay? So please, if I give you the eigenvector or eigenvalue for the Cannon matrix, how we can find the U and U1 and U2? You remember what we have? We have this one, right? And we have the kernel, right? All is right. If you have the eigenvalue and eigenvector of K, how we can find the eigenvalue and eigenvector for this? It's given in the steps. So he no need to prove. What are the steps to do the kernel PCA? You have it in the slide, right? What is the next step, please? What are the next steps? If I give you what are the next steps, when you get the eigenvalue, eigenvector of the kernel matrix, what is the next? Can you check, please? Did you prepare your summary, your things? What are the next steps?
Yeah, to find the covariance matrix.
Yes, but we cannot find the covariance here. This is the key. Here we cannot find it. Okay, what is the difference between the two, please? What is the difference between the two here? Let's go to the definitions. What is this one here, please? 5 times this one, right?
Yes.
What is this one here, please?
1 over
1 out of n?
Yep.
6, 2.
Yes or no?
Yes.
As in the part 2, we have this type of questions, right? A transpose and A, right? So the eigenvector, they have the same eigenvector. They have the same eigenvector. And if this one, it has lambda, what will be lambda of this one? So only the eigenvector. So almost they have the same eigenvalue and eigenvector, just here because we have 1 out of n, the eigenvalue is changed, nothing else. Please?
Doctor, can you repeat the theory part?
Yeah, here. This definition of K and the definition of segment. If I give you the eigenvector of this one, they're the same the eigenvector of this one. Eigenvalue, if it's lambda, the eigenvalue here is lambda out of n. So here, for example, here, if we have the other one, it was 9, what we divide 9 divide by 2. And here, how to do the projections? The same as we did before, okay?
We divide 9 by 2.
2. By 2. Okay? After we do just the projection, the formula, I just apply the formula, nothing else, right? Phi of x, we have, this is the eigenvectors. Here, K1 is just for normalization, to make the vector as 1. And all the steps here we do it 1, 2, 3. How to do the color? I'm not proving nothing. I'm just doing the calculation directly. So let me start maybe by easy questions and going to the. I'll give you the solutions here.
You will take the values for the projection from the previous.
Yeah, because we have C1, right? We calculated.
Yeah.
Look here, 9 here, right? It's corresponding to this, to the second one. Not one, C1, C2. Yeah, because 0 we don't take it. Yeah? This is the main compound. This is not in our topics today. Okay, this one here, please. If you have this one here, how to calculate the covariance matrix A?
If we have 3 features, 1 over n.
Hmm?
It will be 1 over n. A or A transpose A.
Okay, first of all, what is the size of A, please?
A will be 2 by 3.
Okay, the size of the matrix here, what is it, please? Can you tell me?
2 by 3.
No, here, this one. Not N and M. Give me a value. What is the value here is? 2. What is the value here is? 3, right? Okay. Go now to the first question. Number of features is 3. What does it mean? This is M. And this is N. Is it clear now? Yes? Now, the covariance matrix, which should be 1 over something times A and A. But why do you have to put the transpose? T. In the first or the second? Please. So the transpose here, T. Do you have to put it here or here?
The second one.
But how to answer the question? What is it? So what is it? Tell me. Okay. I give you another question. What should be the size of sigma, please? What is the size of sigma according to the slide?
3 by 3.
Which is m by m. Thank you. Which is 3 by m. So it should be 3 by 3. Excellent. So what you have to put here first? N. What is n in this case?
3.
2. Thank you. What you have to transpose now? First or the second? What is A is? You see? 2. It should be in the first one. Is it clear this? Can you repeat again? Okay. Okay. First of all, size of the covariance matrix is always m by m. Clear? And the specific questions here, they said number of features is 3. So m is here, right? And n is here, correct? The size of this one should be m by n. 1 out of n. So here we have n. N is 2. Clear here? Yes? Now, after the product here, I have to have m by m. What is m here? Size is this one. 2 times 3, and this one is 2 times 3. So if I put transpose here, what will be here? 3 times 2, 2 times 3, which is correct. But if I put the t here, what will be? 2 times 3 here, which will be? 3 times 2, which is 2 by 2, it is not the right one. So to force it, you have to put the t here at the second one. Yes? Okay, now let's do the calculation now. We have everything, right? Okay, so what will be A, please? 1 out of 2. What is A, please? In this specific U sigma dt transpose times U sigma dt. Okay. What will be half? V sigma is diagonal matrix, so the transpose will be here. Ut times U sigma Vt. And you can see here, if you do U times U, it will be additive matrix. You can check it, calculations. So we can, wait, right? Sigma T times sigma, what will be?
Sigma square.
Can we calculate it here?
V is I,
That's it.
But anyway, for me, if you do this one, it's enough for me. Yeah? The calculation at the end, I don't care. What? Sorry?
In the exam, you don't want us to do the equation?
At the end, no, I don't need a numerical value. Yeah. No, for example, here. Okay, so what will be? Let me do it for you here. What will be here? 500 030 times 500 030. What will be the value here, please? 5050 is 20, 25. This is 0, 0. After 0, 9, 0, 0, 0, 0. Okay, you can check. But for me, I do all. If you do this one, is enough for me. Okay. Second one. Now we change. This is M, and this is
Doctor,
yes.
have you proved their equation by this matrix?
Hmm?
Are you proving their equation by this matrix?
Yeah. But here you can check it. You can check it. Is you.
Here is 1 over 2.
Sorry?
1 over 2.
No, yeah, 1 over 2. No, here I'm just doing. I'm just calculating this with this only. This with this only. I don't do the calculation until the end. Just give you a little bit. Clear? It's easy product matrix. I'm not doing it. Second one is will be here. What will be here? If you do this one and this one 3, what will be here, please? 3, and you change the transpose to the other side, and we add down. Here. Did you get all the answers correctly here? This one, covariance matrix.
Yes.
Okay, anything circular, what does it mean? Identity. Any vertical or horizontal ellipse mean is diagonal matrix. Yes? If it's on X, mean the value, the first one is bigger than the second one, eigenvalue. If it's like this, the Y is bigger than X. If it's oblique, like this, negative or positive, you have to see. For example here, this one, the slope is positive, so you have the positive. If the slope is negative, you have both. Okay?
Can we have more of this in the exam?
This one, yes. But I will give you ellipse shape. Is it clear, right? Easy? This one. Let me come back to this one later on. Let me do this. Okay, so if the easy one, just tell me please it's easy one. This one. This one, please. Oh. Did you solve this one here?
Yes.
So you can check the answer, I can upload it. It's just direct calculation. Okay, let's do this one together. How to find the covariance matrix here, please? So when I ask about the covariance matrix, you have to know where is M, where is N. It's very important. Okay? Because the data maybe is given to you like this, maybe the data is on transpose. So you have to be careful about it. So how to find this one, please, here? So here, consider 3 data points in R square here. What is M? What is N?
2 is N.
2 is N? 3 is N. Totally wrong. Okay, how to find it is n or m? From where? Which information? Okay, the data belongs to R square. What does it mean? Two dimensions. What does it mean? Two features. Mean m is 2. It's very important, clear? Did I ask about n and m? I should ask at the beginning what is number of features, what is the size of the sample. Okay. So in this case, what will be the covers matrix, please? What is the formula say? 1 out of n, a times a. The transpose is up to. When we are putting the vector, are you putting in column or row? It depends. So I cannot put the formula always here or always here. We don't know. But you have to make sure that the size should be n by n. So tell me here, what is n here is? 3. Thank you. Well, we have to put the transpose. No, the first one or the second one? Second one, thank you. Excellent. Now it is calculation, right? Yes? Let me check the calculations. Oh, but I did one mistake here. I didn't check if the mean is 0 or not. Mean all what we did is, here what we did, everything is wrong, right? I have to check that if the mean is 0. But by chance, I think ours is 0, right? Yes, okay, see, the sum here is 0, the sum is 0, okay? But please be careful, huh? We have to make the data centered first. Clear?
You have to check the mean first.
Yeah. You see, for example, here, I check the mean is 0.
By summing
After.
each data,
But I asked the first question, find the covariance.
each data point or each feature?
Hmm?
By summing each feature.
Yeah, it's 0, yeah. So we get this one here, 10, okay, we get 14, 10, 10, 8, okay? So it's easy how to find the eigenvalue and eigenvector again, right? So we do.
I'm sorry, just now I asked you to sum by each feature, and you said yes.
Yes. No, sorry, by each n. Yeah, by n.
By n.
Yeah, because when we have the features here, we do summation all on the features, but on different sum. Features 2, this one.
I mean, we take the column and we sum by the feature.
No, you cannot say the column or the vector because the data, I can put it, look, for example, I can put it like this or I can put it like this. So in this case here, what is features? We have and feature 1 and feature 2, right? Okay, so on the feature 1, take the mean here. Feature 2, take the mean. Yeah, by feature. But over n, by feature of.
If the dimension is not given, R square, how will we know if it's feature or not?
Huh?
How will we know about the feature and dimension?
But here he said also 3 data. Mean the size of your sample is 3. You got it? Okay. So please here we find the eigenvalue and eigenvectors. Look, we have two eigenvalue, 0.18 and 7. So what is the main one? Is V2, and we have V1. So the first principal compound is V2. So what we do now? All my data, I do the projection on V2. So what is V2? Transport times X, right? What should be X1, X2, and X3. When we do the projection, we get this value here. They ask what is the variance on the projected data without any calculation is the eigen value. You can check it here. 3.6 minus 0.8 minus 2.7. If you want to find the variance, you will find is 7.14. So now I want to reconstruct my data and see what is the difference by using only one dimensions. We have X, and based on this one here, it is following the direction V2. So we have to make it again to matrix, put the differences, so you can see here. Instead of 2 dimensions, we get only 1 dimension, but the error is still small.
Doctor, didn't we say the variance is the diagonal of the conversions?
Yes, it is random. Because it's labeled, yeah. Yes, correct.
But it's not, it is fine.
Yeah, of course, yeah. So the variance is the eigenvalue, directly, on the projection data. This is not included. Okay, let's start. No, this we did it last time, but I will repeat it again. Yeah. Number 6. Problem. Problem 6. No, I'm coming to those two problems about the ellipse. I'm coming to it later. Hey, please, what is the? Okay, which one? Below show better performance of PCA at the rate of 0.7. Which one? Why is it blue?
Depends on which one, before 0.8 or after.
Yeah, before from 0 to 1, almost an 8, it will be W. At the 8 points, it will be the same, and after that, it will be the red one, right?
But I need another keyword. Why is better?
Because it's reached 0.7 or
Okay, at 0.7, why the blue one is clear? Give me just 2 words, nothing more. Sorry?
Each first.
No, I don't. No, this is
Closer
maybe.
to the
Okay. Look here, at 0.7. I still not the right answers.
I know, doctor, I know.
Okay, let me do it again here. I have this one here, this one here. This is coming like this, and this is coming like this, right? At 0.7 is here, right? Yes?
Yeah.
Okay. So why this one is better?
Because the eigen, we want the eigenvalue to be big and then small.
Yes, but why? To reach what?
To reach the maximum.
Look here, please. At this one here, I can need only, for example, 3. Here I need 7. So at the same compress rate, here I need only 3 dimensions. And here I need 7. So which one is better? The shortest. I compress it better. You see how to answer now? This one is more compressed than this, but we give it the same compress rate. But here we need only 3 area, and here we need 7. Clear now how to answer, please? Because what is our target? You do forget. What is our target of PCA? To compress it without losing information. But if I am at the rate of 0.9, which one is better? The red one. Okay, so I can give in the exam different scenario. Okay, so how to answer the questions? Look to the dimensions. Clear here? So don't forget why we need to do the PCA. If you know the target, you can answer easily. Okay, let's do now the matrix derivative. Okay, what we did here about the matrix, please. If we have this one, what is the derivative of this one? With respect to x, of course, right? A, thank you. The opposite one? A transpose, huh? We do it later on, but just take it like this. It is very simple, I can prove it later on. System of equation, nothing more. Clear this one? Okay, let's apply it. So when x comes first, I have to do the transpose. Okay? Let me clean this one here. Now what we have here, please, xtax divided by
P transpose.
okay. What is the derivative of this one, please? Let's do it first. The derivative of this one, it will be the derivative of this plus Are you okay with this? Yes? What is the derivative of this one here, please? Thanks. plus derivative of this one.
The first one, direction.
Quotient root. What is it? Square. Why square? Because this is value at the end. You have to be careful. It's a value. Derivative of this one times the second one minus times the derivative of the second one. This is right. I will do this one. Okay. What is the derivative of ptx?
It's PT.
When x comes first, it will be the transpose, right? So it will be here p. Okay. I'll do the other one alone. The derivative of the product. Okay, what you have x t a x. Here we have the product rule. So what will be here? X t a x plus a t a x. I will do the derivative with respect to this, and he will do the derivative with respect to the second one. Alright? X comes first. What do you do? Transpose of this, right? Plus x comes second, which will be 8x. Okay? What is the transpose of this one? ATX plus AX. Take x common factor, AT plus AX. Nothing else. Done. If we do this one. So what I did, I just applied, we did it many times, right? So we needed all time to do the optimization in matrix equation. That's it, no, nothing else.
Doctor, in this scenario, A and X both are variables.
Sorry?
A and X both are.
I don't know, the variable is only x. A and B are given, or matrices.
In general, when we are doing any kind of derivation, let's say I have a number 2x, and if I want to take the derivative of 2x, it will be 2.
Yes.
Is it?
But when x is variable,
Yeah.
when x is vector or matrix, it's different. Yeah, because we have x1, x2, x3.
Because in here we are skipping x transpose, and
Yeah.
we are writing only ax.
I didn't get you, sorry.
In this second part.
This one?
Yes, sir. X transpose ax.
Yeah, because this one, it is a product rule, derivative of the first time, the second, plus the second time, the first derivative of the first one. That's all. Yeah, it is product rule.
Doctor, why we call it quadratic?
Hmm?
Why is it quadratic function?
This is quadratic because we have x times x is x squared. Yeah, but we don't have, we cannot write in matrices x squared. So we do the product, right? It's quadratic. Okay. 3.
It's easy.
Easy for all, sure, please?
Yes.
Sure? Okay. 4. For this one. Equidistance.
Yes.
What the range minus 6, you get it here. I have the solution at the end in case. We have the solution. Clear? Sure? This one here. This is also is integration, nothing else. But you have to find the equation of the graph. The graph, it is a line. How to find the equation of the line, please? Okay. So please take this one as formula. Y minus y0 equals to m times x minus x0. Y0, x0 is any point on the line. How many points on the line we have? 2. You can take the first one, 2550 or 55, one out of this one. So the easy one I prefer to do 25500. Correct? Yes? Done. Next one. What is the slope? So n I'm sure is negative, right? What is the slope? The opposite divided by the adjacent. Tangent theta, right? What is the opposite? 1 out of 200. What is the adjacent of the triangle? 255 minus 55 is 200. What does it mean? 1 out of 200 square. I find my equations. So how to write now the equation f of x, please? F of x equals to 0 if x is less than 55. If x is bigger than 55 and less 255, what will be here? Minus 1, 200 squared times x minus 255. Done. Okay? This one I need to integrate it. The formula said, what is the formula, please?
It's L minus
255 integration from 0 to r f of x dx, yes? What is the integration? Is the area, right? Look at, if you are at 0, until 40, 0, 45, 0, there is no area, until 55. So what we can say here, this equals again to 0 if r is less than 55, yes? Because until r area, there is no area. Now, if r is bigger than 55, what will be the area? From 55 until r. What is the equations here is
number 6.
x minus 255 divided by minus 200 squared dx. And this is very simple integration. I want to do it. You can do it. Is it here what I did? I just find the equation of f. I just integrate it.
Square the x1 or not?
Sorry?
We should square
Okay. Clear or not? So when you do this integration, your histogram became uniform histogram of your image or video or signal.
And that's it?
That's it.
If it's greater than 255, isn't it 1? Or
Addition by part.
if it's greater than 255?
And because the range of the image we take only 2. If it's bigger than 255, what will be? We can add it. It will be 1. Because this is PDF at the end. But with the density function, so the integration is 1.
So it will be like
Yes, but we don't consider. We're taking only until the boundaries is 0 to 255.
I saw the example. This will be sketch.
Yeah,
So-
sketch the transformation of the function. So this one.
We have to integrate first to get the sketch.
Now, if
And
you
we
give me
can-
this one here, I will accept it. You don't need to go more in details. So you give this formula, it's fine.
Yeah, we can.
But
have-
if you want
we
to
can
sketch
use-
it, yeah.
We
How to
can
sketch?
use the sketch. And
Yeah.
It's just
How to sketch? Let's do it here. You are right. Let's do it here. Look here, please. You have this one here.
yeah.
How to sketch the integration, please? What does mean integration? Area, right?
Yeah.
Yes? So the area, what should be? Here is 0, 0, right?
Mhm.
And at the end, I have to reach 1. Because we probably, right? Here the area is, here when we have x, the integration of x, what is it? X squared. No. If you want to, but it comes also from the same item. Yeah? Because we reach, and until the end it will be here, everything is if1 if you want. Yeah? It's like cumulative distribution function with a probability density function for those who are good in probability. Number 6. It was difficult or easy? We can solve it together? I'll solve this one after we take a break. What is the formula that we have, please? What is the formula for the entropy, please?
Summation I equals 1 to b dot.
Yes, it will be h of the s. It is minus b ln p minus 1 b ln of 1 minus b, right? What is the probability for p?
It will be
1 out of 3 out of 6, right?
yes.
The other one is same thing, right? What we get here? I think log base 2, sorry. Yeah?
Yeah.
Yes, log base 2, thank you. Log base 2, log base 2. Okay, is 1. Now, how many possible separation we can do? How many possible separations? Okay, how many data we have here? 6, right? How many possible?
3.
Yeah, in general, not in specific case.
5.
If you have n data, how many possible separation? N minus 1. If you have 5, here at the middle, right? Exactly. So in this case, we have 6, we can do 5. But we can see Q and Q, there is 3 consecutively, right? So it's better to, what will be here? 1, 2, 3 only. Even I can say 2. But here, if it, yes?
2 is sufficient.
Yeah, 2 is in this specific example.
Yes.
For example, here, if you want to guess what is the best separation without doing calculation.
17.
So give me a value, it's between 16 and 18. So we can say 17. 17.2 is wrong or correct?
Correct.
Any value between 16 and 18, but the boundary not included is correct.
So we can guess the optimum one and solve it.
Yes, exactly. Yeah.
Yeah.
But you have to take the risk of the guessing. Maybe it's correct, maybe it's not. Okay, is it clear here? So if we can check here, if we can separate the data, I think I solved it here. Let me do it here again directly. Number 6.
Why you are not including the values?
Because the separation should be cutting here. You cannot cut here. So is it clear here? We calculate, we get 1. Now, if I take 2 here, for example, I said we can take in this region or this region. Here and here and here, we make it more complex, right? So what we want to separate that we have the 2 classes that are most pure as possible as you can. Make it pure. Only 1 class, right? Clear? So if we do separation here, what should be here? We have S1 and S2. What is the entropy for this? What is the entropy for this? When we have a pure class, what is the entropy, please?
0.
Okay, what I mean entropy?
There is no information.
To quantify the information that you will give me.
Yeah.
But if the data is everything the same class, I'm sure that what you will give me. There's no information given. So the most important one there is equiprobability. If there is 2 samples, 50-50. If you have 3, 1 out of 3, 1 out of 3, 1. So they have the same probability, uniform. When it is uniform, we are getting confused. Clear? If something is 80% and one is 20%, I know most likely it's coming from the 80%. Clear? Anyway, this is clear here, calculation? Just to apply the formula and you can see the maximum is getting between 16 to 18. Okay? You take 16.1, 16.2, 18, 17, and so on. Anything value, right? Please tell me yes or no.
Yes.
Yeah. So where we stop? Okay, we take a break and we come back to finish this. Okay. So please, every time when you are facing difficulty in linear algebra, this property, just write it down. This is how to do. And it will be repeated again and again. We're doing maybe 20 or 15th idea, and always I'm repeating them at all. But for you, when you don't memorize them, for you it seems that it's a new idea. No, it's just repeating it again and again. Okay? So please write it down, how it works, how things. For example, today, how to repeat the mean, how to find the average. Just write it down. You'll need it later on. So we come back after 7 minutes, please, because I need to finish all